Hi there. My name is John Strussi, and I'm going to be your instructor for MAC 2311 Calculus 1. So in these first few lectures, our goal is to just review concepts from pre-calculus that we should know. So these first 4 lectures are geared towards that. And then after those, and hopefully after I get used to this whiteboard situation, this is my first time using this ever, after the first 4 videos, we're going to get into the calculus material later. So in this first lecture, I want to go over these things here. So recognizing linear equations, solving equations, inequalities, and the definition of absolute value. So these are all things you should have probably seen in high school, but we're just going to go into it in a little more detail. All right, so let me first write down what a linear equation is. So a linear equation in X has the form AX plus B equals C, where A, B, and C are constants. So in X means X is our variable. Generally, it's what you want to solve for, or the quantity that's unknown. And then what I mean by constants is just A, B, and C are regular old numbers. Like this could be like 4, and this B could be 1, for example. So by constants, I just mean non-variable terms. Let's try solving an equation. Let's bring back the memories of solving equations from high school. So we have X plus M. M is going to be a constant, over mx plus 5 is going to equal 1. So let's go ahead and kind of get rid of this denominator. We're going to multiply both sides by the denominator because it kind of undoes the division that's here. So that'll look like this. I'll have mx plus 5 and multiply it onto both sides, just like this. OK, I'm going to step over here. I hope that helps you see what's going on. I don't want to block anything. I think maybe I'll just wear like a solid black shirt and be a floating head for the videos in the future. OK, so if you multiply both sides, this cancels out, and you get x plus m equals 1 times anything is itself. So you just do mx plus 5 here. I'm still trying to solve for x. That's my directions here. Probably should say that's what we're doing, solve for x. I'd like to get all the x's on one side. So this thing has an x right here. I'm going to move it to the left. To do that, I subtract. So I get x minus mx equals, let's take this m and subtract it over here because it doesn't have an x. So it'll be 5 minus m. So we've kind of just rearranged everything. Both of these terms have an x in it. So you should be thinking to factor. So that's what I'm going to do. I'm going to bring the x out front. So x is going to go in front. Remove it from each of these terms. You get a 1 for this one. What's left here, the m is still here. So you get m. And that equals 5 minus m. OK, I have 2 things that are multiplied together. Remember, if they don't write it and the letters are just next to each other, you can assume it's multiplication. So to undo the multiplication, I divide. So let's divide by this, 1 minus m. So x equals 5 minus m over 1 minus m. And that was OK as long as 1 minus m wasn't equal to 0, right? So we can divide that over. And there we go. We've solved for x. This looks like a linear equation because the powers of x here and here are 1. That's the most important thing about being a linear equation, is when you see the x's in the equation, the only type you see is to the power of 1 and like no other types. OK, so that was solving a linear equation. Next, we're going to look at some inequalities. OK, so now let's take a look at inequalities. So let me write down the definition. We have an inequality compares 2 values And let me give you the notation for that. So we could write something like A is greater than or equal to B. So that's what that would mean in English. So we have A is greater than or equal to B. Another one we could do is A is less than B. So I'll write that down too. A is less than B. So the important thing with these is you don't just have one singular value as the answer. You have a range of values, and it's a comparison. It's not just like a strict equality. So if you don't have a equal to symbol, then we call this strict. So this is A is strictly less than B. OK, so let's look at an example of an inequality. So we're going to do, as our example, we'll have 2 over x minus 3 is less than or equal to 2. So we're going to solve this inequality. First things first, I'm going to subtract this 2 over here. So I'm going to get 2 over x minus 3 minus 2 over 1 is less than or equal to 0. Now, you might be asking, why didn't I just multiply both sides by x minus 3 like the equation? Well, the problem with that is the inequality sign can flip if you multiply by a negative number. And I don't actually know right now if this is negative. So let me just do like a little sidebar here, a side bubble. So if x is less than 2, for example, if you multiply both sides by -1, you would get negative x is bigger than -2. So multiplying by a negative number will flip the sign. And because this is unknown, I don't know if I'm supposed to do that or not. So the safest option here, what you should do, is you're going to subtract the 2 over. Next, I'm going to get a common denominator. So it's going to be x minus 3. So I need to multiply this by x minus 3 over x minus 3. So if you multiply this by x minus 3 over x minus 3, you get 2 times x minus 3 over x minus 3. This is still less than or equal to 0. From here, because they have a common denominator, I can combine the fractions. So I'm going to get 2 minus 2x minus 3 over x minus 3 is still less than or equal to 0. From here, I'm going to go over here. So distribute the -2 to the x and the -3, and you're going to get 2 minus 2x plus 6 over x minus 3 is less than or equal to 0. Next, what I'm going to do is combine like terms up here. So I'll get -2x plus 4. Sorry about that, it's 8. So -2x plus 8 over x minus 3 is less than or equal to 0. Now I'm going to factor. So I'm going to factor the numerator, and I'm going to get, I'll factor out the -2 as well. So we'll get -2x minus 4 over x minus 3 is less than or equal to 0. And what we need to do from here is we need to figure out when this quantity on the left is less than or equal to 0. So we split up the possible values where the sign can change on a number line. So these are all of our critical numbers. So one of them is 4, because if you plug in a 4 to the numerator here, you get 0. And the numbers around 4 would change sign. So 4 is one of our test values. 3 is another one, because it changes the sign down here when you're either a little bit bigger than 3 or a little bit smaller than 3. So where it goes undefined is another test value here. And those are the 2 test values. So we need to pick like a representative from each one. So let's pick easy numbers. Let's choose 0 and plug it in and see if it works. So if you plug in 0 in the numerator, I'll write what it is right here. If you plug in 0, you're going to get -2 times -4, if you plug in 0, over -3. This right here, this overall is a negative number. So this is saying a negative number is less than 0. This is true. So that just means that this works. So this whole interval is going to be included in my solution. Okay? Now I'm going to try the next interval. So let's plug in, I don't know, 3.5. So you'll take 3.5. You'll go back down here. If I just write the signs of what's going on, I have a -2. Then right here for this, a 3.5 minus 4, that's also a negative number. And then on the denominator here, 3.5 minus 3, that's a positive number. So overall, what type of number is that? Well, this would give us a positive number, because two negatives cancel. However, that would make this false. It says the left side is positive, and it's less than 0. That's false. So that's not true. You can check for yourself, say if you plugged in 5, that this one also works as well. So you have the three intervals are good, bad, and good. The last question is, what am I going to do about including the 3 and the 4 in the solution? You would never include 3 because it makes the denominator 0. That's very bad in math. You would include the 4 because it makes the numerator 0, and that's OK, because 0 equals 0. You have the equals 2 sign. So that's OK. So I'm going to include the 4 by putting a bracket. I'm going to exclude the 3 by putting a parenthesis. And this is my solution to the inequality. So it's all of these numbers make the original problem true, original statement true. So here we have 3 different equations that we're going to solve. There are 3 different types of equations. So just to give you a broad overview of equation solving from past classes. This first one here is some polynomial equals 0. So a very common technique used to solve equations is factoring. So we're going to practice factoring. What do both of these terms have in common? They both have x squared in common. So what you're going to do is you're going to factor this out. So in front, I'm going to write x squared. And you're going to imagine bringing that out of each of these. So if you remove x squared from this one, how many x's are left? Well, it's just 1x. And if you've removed both of these x's here, you need a 1 to hold the spot there. So now we have one factor times another factor is equal to 0. So what that must mean is that either this first factor, x squared equals 0, or what could happen is you have x minus 1 equals 0. And this property where you set each factor equal to 0, that only works if there's a 0 here. You can't do that for some other number over here and set it equal to that number. It must be 0, so remember that. Now we have 2 other equations to solve. This one, if I take the square root of both sides, I'm just going to get x equals 0. And then for this one, the one step I need to do is add 1 to both sides, and I'm going to get x equals 1. So these are my 2 solutions to the original equation. Let's look at this one. So it looks a little more complicated, but it is just a standard factoring problem. How many m's are in common here, or what power of m do you see that is the least? Well, here's a 2, and here's a 1. So I'm going to factor out m to the first power this time, because that's the smallest power I see. If you look at the numbers as well, I have an 8 and a 2. So 2 is the greatest common factor that is factored out. We also have this m minus 1 factor in each of these. And the powers are weird, but you just need to look at the smallest power again. So out of 1/3 and -2/3, what is the smaller number? It's this one. So that's how you know which one to factor out. So you're going to also factor out m minus 1 to the -2/3, purely because that is just the smallest power. All right, I'm going to draw a very large bracket here, and I'm going to write what's left, just like I did up here. I factored out of 2 terms. These are just 2 giant terms here. I'm going to factor this out. 8 divided by 2 gives me 4. M squared divided by 1m leaves me with 1m left. Here, the arithmetic's a little tricky, but you just take this power, 1/3, minus the factored out power, so 1/3 minus a -2/3. That's a double negative. And you're just going to get m minus 1. And then 1/3 minus a minus 2/3, that's actually just 1. So I don't actually have to write that. That's just the first power. Then I'm going to do plus. 2 divided by 2 gets me 1. M divided by m gets me 1. And here I've exactly factored out this as well. So I need, just like this last one, I need a 1 to hold my place there. If you're ever unsure whether you factored correctly, you can take this factored out term here, this GCF, distribute it back in, and see if you get the line above. So if you did that with this one, you would also get the line above. All right, so same strategy as before. I'm going to take this first piece here, 2m, and I'll set that equal to 0. Or this could equal 0, so I have m minus 1 to the negative 2/3 equals 0. And my last factor here, well, I need to do a little more work. So if I take this 4m and distribute this in, I'm going to get 4m squared minus 4m plus 1. And that's supposed to be equal to 0. Let's take a look at this first equation. So 2m equals 0, that means m has to be 0. You just divide both sides by 2. What's going on here? Well, recall, if you have a negative power, you can make this positive by bringing this whole expression to the denominator. So I have m minus 1, and this is to the 2/3 power. So that's how you go from a negative power to a positive power. Am I ever going to be able to have 1 divided by some real number is 0? The answer is no. The way you make a fraction 0 is if you have the numerator is 0, right? But 1 divided by some real number is never going to be 0. So in this case, you would just write no solution. There isn't an m value, like a real m value, that's going to make this true. So you just say no solution for this piece. Here's my last piece. How would you deal with a trinomial like this? Well, it's factoring. So what I notice is that 4 is a number squared, 1 is a number squared. So this will factor into 2m minus 1 times 2m minus 1. And if you want, you can check that. You can FOIL this out and make sure you get what I started with here, but you do. So this is a little redundant. It's just the same thing. Each factor equals 0. So I'll just take one of them, set it equal to 0. If I add 1 and divide by 2, m is a half. So for this original equation, the two solutions that I found are m equals 0 and m equals 1/2. OK, and then for this last one here, this is a radical equation. So I'm going to show you how to solve radical equations. What you want to think about doing is you want to isolate the radical. That's usually the strategy for this. So what I mean by that is you get the radical piece all by itself on one side. So I'm going to move this x away by adding. So I get radical 2 minus x squared equals x. So now the radical piece is all by itself on the left side. I'm going to square both sides to undo a square root. So it looks like this. I'm going to square both sides. Squaring the square root removes it, so you just get what's inside, which is 2 minus x squared. Here's another x squared. Now if I add this x squared over to this x squared, I have 2x squareds. And 2 divided by 2 is just 1. So this leaves me with this. I'm going to take a square root of both sides to cancel the square. It's kind of like the opposite of what I just did before. So I get the square root of 1 equals x. However, because I took a square root on both sides of this equation, I need to remember to put a plus or minus symbol. Because you could have had 1 in here, 1 squared is 1. Or you could have had negative 1 in here, squared is 1. So x is equal to 1 and x is equal to minus 1 are the two solutions we get doing this process. However, for radical equations, you must check your answers. And where am I going to check my answers? I'm going to go back to the very original. So here I'm going to check x equals 1. And then I'll also check x equals negative 1 over here. So plug 1 into the original here, and I get the square root of 2 minus 1 squared minus 1 equals. So I plugged in 1 for each of these x's. 2 minus 1 is 1. Square root of that is 1. Minus 1, so I get 1 minus 1, is 0. That's good. That's what I was supposed to get. It's supposed to be equal to 0. So I'm going to accept x equals 1 as a solution. Let's check negative 1. So if you plug in negative 1 into the original, on the left side, I get 2 minus negative 1 squared minus a negative 1. Notice I'm being very careful. By plugging in this minus 1, I'm using parentheses for each of these, just to make sure I don't mess up any signs. So then the exponent goes first here. I get the square root of 2 minus negative 1 squared is 1. When you square a negative, it gets rid of the negative. Here I have a double negative. I get minus a negative 1 is plus 1. The square root of 2 minus 1 is 1. Plus 1 is 2. That's not good, because I was supposed to get 0 based on the original equation, but I've gotten 2. So what we say is that this is an extraneous solution. In fact, it's not a solution at all, so you just get rid of it. So the only solution to this radical equation is 1. So it's important when you're doing radical equations to go back and check your work into the original. All right, thank you so much. In the next part of the video, we'll be doing more examples. So see you soon. All right, so the last thing we're going to talk about in Lecture 1 is the definition of absolute value. So let me go ahead and give that to you right now. So we're going to say, if A is a real number, then we're going to define the absolute value like this. The absolute value of A, it's just itself if A is a positive number or 0, and it's negative A if A is less than 0. So you probably remember this from high school. Taking the absolute value of a number makes it positive. That's the point of this. It measures physical distance. So, for example, physical distance from 0 is what I should say. The absolute value of 4 is just 4. And that's because on a number line, if you're here at 0 and there's 4, you're 4 units away from 0. So that's the reasoning. However, negative 4 is also 4 units away from 0. So that's why the absolute value of negative 4 is also 4. At least that's what we're told. Why it's really equal to this is by this definition right here. So if what you've plugged in is a negative number, so right here I have negative 4, then to get the answer, you need to take the negative of it, if that makes sense. The definition up here says that if you have a positive number or 0, then to get the answer, you just remove the absolute value bars, and that's your answer. So in this example, I had 4. 4 is a positive number, so it corresponds to this first thing here. So 4, the answer is just 4. It's itself. It's A. So summary, you need to check if the thing inside the absolute value bars is positive or negative, and then you're going to either keep what's in there if it's positive, or you're going to flip the sign of it if it's negative. And that's it. So now the examples are going to get a little more abstract, and you're going to have to follow that same kind of reasoning. So let me give you an example. The absolute value of x minus 1. The thing with this is x is not a number anymore. So I can't just talk about it being some kind of distance from 0. I need to know when this thing changes sign, because when it changes its sign, that's when I know to either flip it or keep it the same. So what is the important x value where this whole expression becomes 0? Well, if you set the inside equal to 0, x equals 1 is kind of like the breaking point. At x equals 1, it flips from being a positive to a negative number, like this whole expression in here. So I need to section this off based off of 1, because that's the important spot. So for example, when you're bigger than 1, let's say you're 2, 2 minus 1 is a positive number. So we follow the top line here. When it's a positive number, you just rewrite what's in there. So I'm going to rewrite this. Now when you're less than 1, say you're 0, this becomes a negative number in here. And what happens when you have a negative number in there? You flip the sign. So to flip this, instead of x minus 1, I'll have 1 minus x. So this is how you write this. Again, you need to examine this, and you're going to ask yourself the question, where does the expression change sign? As soon as you figured that out, then you know where to set up your x, where you set up that breaking point where you either keep it the same, whatever's in here, or you flip it. All right, let's look at this final example of absolute value. So let's use the definition one more time. So we have an example, and it'll be the absolute, we'll do x over the absolute value of x. So because of this absolute value sign, we're going to have two cases. When is this expression inside the absolute value positive? Well, that's just going to be when x is positive. So when x is a positive number, we use the first line of the definition. So when a is positive, you just drop the absolute value bars and write what's in there. So this will be x over, then we drop these absolute value bars and just write what's in there. So it's x. However, that's just equal to 1, right? OK. The other thing we need to consider is when is this negative? Well, that's when x is negative. So what do you do when the expression inside absolute value bar is negative? You flip the sign. So instead of x here, we're going to drop the absolute value bars, and it's going to become negative x. We flip the sign. But that's just negative 1. You may have noticed I left off a number here in the domain, right? What am I missing? Well, I'm actually not missing anything, because you're not allowed to plug in 0. We could say at x equals 0, this is undefined. Just like I said earlier, you cannot divide by 0, so we shouldn't include 0 in the domain at all. So that's why it doesn't appear in the piecewise definition. OK, maybe I can fit a graph. Let's graph it like right here. So all it says is when x is bigger than 0, you're equal to 1. So here's 1. And then it says when x is less than 0, you have to graph negative 1. So it's like here. So this is the graph of this function right here. I have open circles to denote that I can't actually plug in a value at 0. OK, so you should have everything you need to attempt your lecture quiz 1. And in the future lectures, we're going to continue reviewing pre-calculus material. OK, thanks for watching.